quadratics. So really we're covering 1, 4, 1, 5 today. We're doing both. And the reason we're doing that is 1, 4 obviously is quadratics. 1, 5 is kind of applications of quadratics. They're going to give you a setup kind of word problem that involves quadratics, and it's just solving them. So it's no real different. They just look different because they're set up in a word problem. They're going to give you all the information you need, either the x-intercepts, they want to find the equation, or they give you the equation and you want to find the solutions. And when we talk about those, it's applying it into a real-world application, a real-world setup. Kind of throwing a football, they give you the equation, how far or how long did it take for the ball to hit the ground, given they wouldn't use x, they would use t as time. Well, most likely we're going to get 2 times. One's going to be positive, one's going to be negative. So we throw out the negative because you can't have negative time. So it's applying some of that to it as well. Now with quadratics, ax squared plus bx plus c, where a, b, and c represent real numbers, where a is not 0. A is different from 0. A quadratic equation in the variable x is an equation of this form here. So we're talking about parabolas, a curve, an arc in this here. Now we say a is not different from 0 because, well, the main part of this equation that makes it a quadratic is the ax squared. If a is 0, we don't have an ax squared term. It's just linear. So we have to have an a value. Now there's different ways to solve these. One of the first ones is by the zero product property. And the zero product property, we've used it before. Y'all know this. And zero product property is pretty straightforward. It's if we have 2 things, 2 or more things multiplied together and equal 0. Well, how's the only way we can multiply 2 things and get 0? As if one of them is 0. That's the only way we can do this. So if we have 2 things multiplied together to equal 0, one of them must be 0. So using the zero product property is helpful. So if we have 2 or more things multiplied together and they equal 0, one of them has to be 0. This is also part of the reason why we get in a quadratic equation higher degree polynomials equal to 0. Because if I can rewrite it, if we can factor it so we have multiple things being multiplied together to equal 0, we can solve from there. Our next one is the square root method. If we have a variable squared equal a number, or a set of parentheses squared equal a number, we can use the square root method, which is essentially just taking the square root of both sides and solving from there. And then we also have the quadratic formula and completing the square. And completing the square is just taking the square root method and being able to apply it to any and all types of quadratics. Now the first one we're going to look at in all of these here is our zero product property. So we have 2 examples with this here. So the first one we'll look at is the x squared minus 8x equals 0. Now we don't have 2 things multiplied together because we have x squared minus 8x, but we do have a greatest common factor between them. And if we factor out the greatest common factor between these 2 here, it is x. And if we factor x out of x squared, we just have 1x. Minus 8 is equal to 0. Now at this point here, we do have 2 things multiplied together. X and x minus 8 equals 0. So one of them must be 0. Well, we already have one of them. X is 0. Now to solve the other one, we would add 8 to both sides, telling us x is equal to 8. And those are our 2 solutions. Now, if we're going to be using the zero product property, one of the things I will say is that, well, the equation has to equal 0 for us to be able to use it. If it equals something other than 0, it doesn't work. So let's look at B. 2x times 2x minus 7 equals negative 12. It'd be very tempting because we do see two things multiplied together to both set them equal to negative 12, but that's not our property. It's the zero product property. We do need to get both of these here equal to 0. So we can add 12 to both sides, telling us that 2x times 2x minus 7 plus 12 is equal to 0. Now we don't have two things multiplied together anymore because we've got two things multiplied together, but we're adding the 12. So we could go about trying to greatest common factor, figure things out, but it's going to be easier to just multiply this out. Whenever we have parentheses squared or something being multiplied and other things being added or subtracted, it's going to be able to just multiply it all out and see what we have. 2x times 2x is going to be 4x squared. 2x times negative 7 is going to be negative 14x. Plus 12 is equal to 0. Now there is a good chance that we can factor this, that there's going to be factors of 4x squared and 12 that will give us negative 14. But is there a greatest common factor between these three terms? 2. I was very tempted to say 4 as well, because 4 does work with 4 and 12, but 4 doesn't work with 14. Now, when we were purely factoring, we would factor that number out and keep it out front, yes? We don't have to do that with solving, because what that 2 is something we can call a scalar. It's making it bigger or smaller. Now, for the most part, if we're talking about the whole function, 4x squared minus 14x plus 12, dividing everything by 2 will change what it looks like. It will change everything except for 2 points. The points that it crosses the x-axis. Those will stay the same. The rest of the graph will look different. So if we divide everything by 2, we get 2x squared minus 7x plus 6 is equal to 0. I think this is easier to look at, easier to work with than 4, 14, and 12. Doesn't change the solution, it changes how it looks, but it doesn't change the solutions. So now we can factor. Or some of this might have been a minute. Our 2 sets of parentheses with 3 spaces. And this is the way I factor it. Not everybody does the same thing, but we do get to the same answers. The first thing I look at is signs. I look at the third term. If the third term's positive, the signs are the same, and they match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the 6 is positive, so the signs are the same, and they match the sign of the middle term. So we have negative and negative. The next thing I look for is factors of the first and third term. If there's only one set of factors, I throw them in first, between 2 and 6. And x squared. So x squared, well, the only set of factors for x squared are x and x. And our only factors of 2 are 2 and 1. Now we do have a few more factors of 6. We have 1 and 6 or 2 and 3. And out of this here, we can try 2 and 3 first because, again, our number is smaller for the middle term, so we're looking for kind of probably some smaller factors. So we can do 2 and 3. And we'll want to set it up this way here, because if we did it the other way, 2x minus 2 would have a greatest common factor of 2, yes? Well, we removed all the greatest common factors. So if there's not a greatest common factor here anymore, there can't be one in either parenthesis. There's not, if we got them all out of the original equation, there can't be one in either one of these parentheses. And if we check this here, check the middle term, 2x times negative 2 is negative 4x. Negative 3 times x is negative 3x, which does give us the middle term of negative 7x. Now, I'm under the notion that we don't have to multiply the whole thing out, because doing 2x times x, well, where did we get it from? 2x squared. If they're factors of 2x squared, they should multiply back together to be 2x squared. The same with 3 and 2. Now we do have two things multiplied together to equal 0. So one of these must be 0. Either 2x minus 3 is 0 or x minus 2. So for 2x minus 3, we would first off add 3 to both sides, telling us that 2x is equal to 3. Then we would divide both sides by 2, telling us x is equal to 3/2. On the other side, we can add 2 to both sides, which will tell us x is equal to 2. So these here are our two solutions. Questions on this here? So they will equal 0. The first one worked out that we had a variable equal 0 because we had a greatest common factor. And that's one good thing to notice. If the equation you're solving, quadratic or higher degree, if we do not have a constant term, if there's a greatest common factor of a variable between all the terms, 0 is going to be a solution. So if we didn't have the plus 12, 0 would have been one of the solutions. Like we had on the first one, x squared minus 8x. 0 is going to be a solution. We don't have a term without x. And the number of zeros that we have will be dependent on the smallest exponent. So if the greatest common factor was x squared, we would have 0 twice. Or if it's x cubed, then it's 3 times. Kind of tells us how many times zeros will occur. Questions on this here? Square root property. If x squared equals k, then x is equal to plus or minus the square root of k. Just a square root method. And this is somewhat of the base to completing the square, because it also works out as if we have x minus h squared, we can square root both sides and say x minus h is equal to plus or minus the square root of k. And then we can solve from there by adding or subtracting h over to get our answer. So it works with either set. The first type, if x squared equals k, if we have x squared, a variable squared, and a number, we can use the square root method. If we have a set of parentheses squared, and all the other numbers outside of it are just numbers, we don't have a variable outside of the parentheses, then we can use the square root method. So like looking at the first one here, x squared equals 64. It's already set up in the form that we have. Because when we use the square root method, we want to get whatever's squared, the variable squared, set of parentheses squared by itself. If they gave it to us there, then we will square root both sides. And the square root of x squared is x. And the square root of 64 is 8. But we have to add the plus or minus. Because with any quadratic, we will have two solutions. They may not be unique solutions, but we will always have two solutions. And when I say unique, I mean having positive or negative 8. Because we can have some where the answer is 8 and 8. It's the same number. But we'll always get 2. Now the reason we add the plus or minus is because 8 times 8 is 64. We know that. We've done that years and years. But also negative 8 times negative 8. Negative times a negative is a positive. So 8 times 8 gives us 64. So we'll have the positive and negative. Anytime we take the square root of both sides, we have to add the plus or minus. Have to add it every single time. Questions on this here? All right, let's look at the next one. 2y squared plus 36 equals 0. This is going to be the same thing. We can use the square root method with it. One of the main giveaways that we can use the square root method with this here is if we have a b term, a bx, or here a by term. Do we have y to the first power? No. If we don't have y to the first power, we can use the square root method. And the first thing to do with the square root method is to get here y squared by itself. So we can subtract 36 from both sides. which will tell us that 2y squared is equal to negative 36. So we know we're going to have complex solutions. The next thing we can do is divide both sides by 2, which will tell us that y squared is equal to negative 18. And last but not least, we can square root both sides. So we'll have y is equal to plus or minus. So we have negative 18, yes? The negative is going to come out as I. I leave a little bit of space because we will simplify 18. And at this point here, you could grab the 30xx and say second square root 18. And it is 30 squared root of 2. Now, we didn't put negative 18 in there because, 1, this calculator can't handle it, and 2, we already simplified the negative part. So your answer is y is equal to plus or minus 3i squared root of 2. On the homework, you're not going to be able to use the plus or minus. What you're going to have to do for a problem like this here is say y equals 3i squared root of 2 comma negative 3i squared root of 2. You're going to have to split them apart. There's 2 separate answers. And be paying attention on what it asks for especially quadratics, because there's going to be some of them, it's going to say round to the nearest 10th or round to the nearest 100th. And a good little giveaway that it's going to be asking for that is, well, as you did the whole section on 1.3 where it gave you the ability to put the radical in, that option's not going to be there. So then if it's not there, check and see what it's asking for. Now we have one last one for this here, w plus 3. W plus 3 squared equals 8. So on the first two, we had a variable squared. Here, we have w plus 3 squared. Now, the way that we know that we can use the square root method for this here is because where is the only variable? It's inside the parentheses squared, yes? If it's inside the parentheses squared, nowhere else, we can use the square root method. Our first main thing is to get any numbers outside those parentheses. We're not worried about the plus 3 yet. Any number added or subtracted outside, multiplied in front of those parentheses. We want to get them to the other side. So if there was a 2 out front here, we would divide both sides by 2. If we had plus 2 or minus 2 here, we would move it over because we want those parentheses squared by themselves first before we do anything else. Because once we get it here, I can square root both sides. Because over here, we're going to have plus or minus the square root of 8, which is 2 square root of 2. So we have plus or minus 2 square root of 2 over there. And when we take the square root, what are we looking for? We're looking for what times itself gives us what's inside these parentheses here. Well, instead of parentheses squared, we're just saying that w plus 3 is being multiplied by itself, yes? That means it's just going to simplify to what's inside the parentheses, so w plus 3. Now, unfortunately, w is not by itself, so we need to subtract 3. And that's it. Now, when you do add or subtract something, you put it in front of the plus or minus. So here, when we subtracted the 3, we put it in front of the plus or minus, and then we would simplify from there. Because the plus or minus is really saying that the 2 squared root of 2 is both positive and negative. It's 2 different values. So we leave it alone until we kind of break it apart and go from there. If it wasn't the square root of 2, we could actually add or subtract. If we'd had, say, 9 instead of 8, plus or minus 3, we can add, subtract, and go from there. Questions on this here? Now, as I said already and kind of hinted at, the completing the square method, which we went through in Algebra 2, is essentially taking the square root method and making it work for any and all quadratics. Because the square root method will not always work if we're not given a single variable squared, so just x squared, or a set of parentheses squared already. But we do have something called perfect square trinomials. So where we can have an expression like this here, x squared plus 18x plus n, be rewritten as x. So this here would be plus a number in parentheses squared. We can rewrite it back as a single set of parentheses squared. Now to be able to do that, we called it c, because it is c, our constant term. We need to find that value. And it works out that there is a method to do that. And what it is c is equal to b over 2 squared. C is equal to b over 2 squared. And in this case, they're saying n. So for us, our b value for the first one is 18. So we're going to take 18 over 2 and square it. Now for most, it's very tempting and it's not wrong to go on and just plug this thing into the calculator and figure out what it is. But I find it very helpful to see what 18 over 2 is. It's 9. And 9 squared is 81. Okay? So what that's telling us is that the perfect square trinomial is x squared plus 18x plus 81. Because if we had that quadratic, it would be a perfect square trinomial that will factor into x, either plus or minus. In this case, it's going to be plus a number. Now, normally we would go back through factoring, figuring out what we would have two things multiplied together and go from there. Now, it does work out that whatever's inside this parentheses, before we square it, is what goes in here. So since we have positive 9, this is going to be x plus 9 squared. That's how it factors. This is also why I say, or kind of suggest, to not just plug parentheses 18 over 2, close parentheses squared, hit enter. Because simplifying the 18 over 2 will help us figure out what goes inside the parentheses. Now let's look at the next one. X squared minus 13x plus n. So in this case, n. I'm just using n because that's the variable that they gave. We can think of it as n or c, either one, is equal to b over 2. In this case, our value of b is negative 13. Does negative 13 divide by 2 nicely? No. So personally, I would leave it as negative 13 over 2. I'd just leave it as is. Because especially when we get to solving, it's going to be easier to leave it as fractions than it is going to be to deal with it as a decimal. Now we just need to square it. We know for sure that it's going to become positive because a negative squared is positive. 13 squared is 169. 2 squared is 4. So our quadratic is x squared minus 13x plus 169 over 4. That's what our quadratic would be. Now, if we want to factor it to a set of parentheses squared, we'll always have x. And the number inside is what? Negative 13 over 2, yes? So that means our sign is going to be minus 13 over 2. And that's it. And it still works the same with fractions, because we can say here n is equal to b is 4/7 over 2 squared. Now at this point here, we can do 4/7 over 2. We can plug it into a calculator to see what this is. And it actually reduces to 2/7. And if we square this, we get 4/49. So our quadratic is x squared plus 4/7 x plus 4/49. And if we factor this, well, our number inside the parentheses before we squared it was 2/7, and positive, so it'd be plus 2/7. So the method is the same. It doesn't matter what the number is, positive, negative, fraction, whole numbers. It's going to work out the same way. Are you ready for the next part? So the next part is actually applying this, completing the square and solving it that way, and using kind of the square root method. And one of the first things we really need to do for this here is we need to get x squared and x on the same side, and we need to get the number on the other side. So what we can do with this here is, one, add 10x to both sides. And we can also add 3. Because we'll need to get the -3 to the other side away from x squared, and we need to get the 10x next to the x squared. What this will give us is x squared plus 10x plus blank is equal to 3 plus blank. I leave the blank in there because, again, we need to make the x squared plus 10x be a perfect square trinomial. And we're going to have to add whatever that value is to both sides. Now for us here, c is equal to b over 2 squared. Well, our b value in this case is positive 10. And luckily 5, or 10 divided by 2 is 5. It's a nice number. And 5 squared is 25. So for this problem here, we're adding 25 to both sides. Now 25 plus 3 is 28. Now the number inside the parentheses before we squared it was positive 5. So x squared plus 10x plus 25 will actually factor to x plus 5 squared. Now, in some of the assignments, it is going to ask you to give this as part of your answer because it's going to be 2 parts. One's going to ask for the solution, and one's going to ask for it to be factored into this set. So you'll put that in as your first answer. Now, the next thing we're going to have to do is square root both sides. And if we square root both sides, these will cancel, telling us x plus 5 is equal to plus or minus. So the square root of 28 is going to be 2 square root of 7. And again, TI-30XS will do those simplifications for you. And last but not least, we need to subtract 5 from both sides, telling us x is equal to -5 plus or minus 2 square root of 7. Questions on any of this here? Hopefully most of this is coming back to you. You're remembering it from what we've done before. It's not too big of a jump. All right, so we'll do this one by completing the square. And one of the biggest things with any of these here, with completing the square, the term in front of x squared has to be 1. Has to be 1. So what we have to do for this here is we actually have to divide everything by -2. Because we need the term in front of x squared to be 1. Positive 1, specifically. Because -2x squared divided by -2 is positive x squared. -3x divided by -2 is going to be plus 3/2 x. And -5 divided by -2 is going to be plus 5/2 is equal to 0. So on some of these here, it is nicer to use the quadratic method for it. Now our next main step is to get x squared and x by itself, so we'll subtract 5/2 from both sides, telling us x squared plus 3/2 x plus blank is equal to -5/2 plus blank. So we set it up now so that we can find c. which is equal to b over 2 squared. So the first thing we'll have to do is divide by 2, which tells us that this is 3/4. And 3/4 squared, well, 3 squared is 9. 4 squared is 16. Lovely. It's clear. Negative 5/2 plus 9/16 is negative 31/16. Now that's halfway nice because 31 is not a perfect square, but 16 is, so the denominator will simplify. Now our set of parentheses squared over here is going to be x. Well, the number inside the parentheses before we squared it was positive 3/4. So this here is going to be the first part of your answer most likely. And then the next thing we're going to need to do is square root both sides, which will tell us that these cancel. X plus 3/4 is equal to plus or minus. We can think of this as the square root of negative 31 over the square root of 16, because we can split it to the top and bottom. Now the square root of 16 is 4. Can we take the square root of negative 31? So we will have I. And we could grab a calculator and say second square root 31, and it'll tell us it is indeed the square root of 31. So the square root of negative 31/16 is the square root of 31 over 4i. And last but not least, we need to subtract the 3/4 from both sides, telling us x is equal to negative 3/4 plus or minus the square root of 31 over 4i. Unfortunately, the program's going to make you put that in twice. One is the plus and one is the minus. It's a positive and negative case. Any questions on this so far? The only other one that we have is the quadratic formula. Quadratic formula is the nicest one out of the group because once we get ax squared plus bx plus c equal to 0, we just plug a, b, and c into the formula. So this here we'll solve using the quadratic formula. Because one of the first things we'll do is actually get it back into standard form. So we'll need to multiply through by x. X times x is x squared. Minus 6x is equal to 3. At this point here, we'll subtract 3 from both sides, telling us that we have x squared minus 6x minus 3 is equal to 0. So our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. A is the number in front of x squared, b is the number in front of x, and c is the number by itself. So we say negative b, we'll have negative negative 6 plus or minus the square root of negative 6 squared minus 4. A is 1, c is negative 3. All over 2 times 1. Questions on this so far? Now at this point here, we can simplify some of this here. Negative negative 6 is going to be positive. 2 times 1 is 2. Inside the radical, we can go on and plug that in a calculator. Negative 6 squared minus 4 times 1 times negative 3 is 48. Now we can take the square root of 48, which is 4 square root of 3. And this here is technically the correct answer. This is the correct answer. There's a good chance that if you plug this in, the program's going to ask you to simplify it. Because if we look at the two numbers on top, 6 and 4, are they divisible by 2? Yeah. So we can divide both of them by 2, because 6 over 2 is 3, 4 over 2 is 2. So this here, 3 plus or minus 2 square root of 3 is the simplified answer. That's it. Questions on this here? We'll come back to that in a little bit. Well, yeah. I want to jump to the end because I want you to at least see some of these here with word problems or type of word problems that we're using to apply these quadratics to. So the area of a rectangle, I normally draw a rectangle, is 120 meters squared. The area is 120 meters squared. The length is 2 more than 3 times the width. So the width is W, the length is going to be 2W, is 2 more than 3 times the width. So 3W plus 2. 3 times 2 more than 3 times the width. So are we good on how this is set up? So the width is W, the length is 3 times W plus 2. Now area is length times width. Well, our width is W and our length is 3W plus 2. And it's equal to 120. Because length times width is the area, so our length is 3W plus 2, and our width is just W. Questions on how we've got this set up? Now from here we're just solving. So we can first off multiply by W, which will give us 3W squared plus 2W is equal to 120. Now we do need this equal to 0, so we'll subtract 120 from both sides. Telling us that 3W squared plus 2W minus 120 is 0. Now we can't use the square root method outright because we do have a middle term, but we could go through the completing the square method. Or we can go through the quadratic formula. Here, we'll do one more with the quadratic formula because we did 2 with completing the square. So negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, and a is 3 times c, which is negative 120, all over 2 times a, so 2 times 3. So you don't have to rewrite the quadratic formula each time you solve it, but it would be good to have it handy so that you can make sure you're plugging in the correct numbers in the correct spots. Now there's a few things we can simplify. Negative 2 is just going to be negative 2, plus or minus. 2 times 3 is 6. So we have 2 squared minus 4 times 3 times negative 120, not 129. And we get 1,444. Yes? We know for certain We're going to take the square root of it. This is going to be 38. Now, on most problems, again, I would say write the radical and do it there. For problems like this here, for these word problems, you want to plug it in. This is one of the few times I will say typing the whole thing in with the radical is going to be okay. Because what are we talking about? We're talking about lengths of a rectangle, yes? Lengths of a rectangle have to be real numbers. They have to be. So typing the whole thing into the 30xs is fine because we know whatever number we get out will not have I. That's the only one that the 30xs does not like, having those imaginary numbers. Now, we need to finish solving from here. As we have x is equal to 2 plus 38 over 6, and we have x is equal to 2, negative 2 minus 38 over 6. Well, negative 2 plus 38 is 36. And 36 divided by 6 is 6. Yes? And this is our w, really. On the other side, negative 2 minus 38 is negative 40 over 6. And negative 40 over 6, so 36, I believe is going to be negative 6 2/3. Negative 40 divided by 6. Yep. Negative 6.6 repeated. And that fraction doesn't mean anything. It's really, well, it's not that it doesn't mean anything. This answer doesn't help us. Because as we said, we're talking about length and width, yes? Can a length or width be negative? No. So this here is what we call an extraneous solution. It's a solution that does work for the problem, but does not fit the original situation. So our width is 6. The length we said was 2 more than 3 times the width. Six times 3 is 18, plus 2 is 20. We also have that what? Length times width gives us the area, yes? If the area is 120 and the width is 6, 120 divided by 6 is 20. And that's it. Questions on this here? Because these word problems aren't that much different than what we've been doing with quadratics or what you've done with quadratics before. It's just applying that same kind of setup. Get it set up, write it out, draw it out, and go from there. All right, guys. That's all we'll have to say for this. And I'll talk a little bit about discriminant tomorrow, just as a blurb before y'all get started, and y'all can have the rest of the time to work on the